Path Robotics, we are building physical AI for manufacturing. So we build a sensor stack as well as an AI model called Obsidian that allows traditional robotics to be more adaptable, to be able to actually look at what's in front of them and decide in real time how to perform manufacturing tasks. That's mostly in welding, as you're seeing on this torch here with that added intelligence that allows these robots to scan every single welding seam and then in real time decide how much should go and weld that part. This is opening up tons of applications for welding automation that have never been possible before due to part-to-part variation, poor fit up, all these things that have limited traditional robots from working in these applications like shipbuilding, utility poles, data centers, etc., allowing for incredible quality and throughput. There's a massive welding shortage here in North America. The ability to add capacity without this headcount that we talk to customers every day that say, if I don't find a solution for my labor challenges, I'm gonna have to close my doors. I've had roles open for years. Every week, another guy leaves for another dollar across town. So the ability to add some capacity, add some throughput in ways that have never been possible with automation before has been really, really exciting to see at Path Robotics here. Just this year alone, the amount of money being spent on data center fabrication is insane. Everyone likes to talk about chips when you're talking about data centers, but all of those chips sit on steel racks with cooling systems and skids, mobile power generation, fuel tanks to power that. All of that stuff is welded steel, and it all needs to be made as soon as possible. So there is just a massive demand right now across both energy, data center fabrication, shipbuilding, that all need technologies like this to help them build faster. You have a couple different robots with a part in the middle that are all kind of working up and down, scanning each seam, working together in unison. Our demo cell here, which is designed really just to show off its ability to adapt in real time to the parts that are in front of it. All of this is happening in real time at the edge, right? So right now it's planning, how do I go from where I am now to roughly where the part is? So it's figuring that out, it's gonna come down, it's gonna scan the seam to understand reality. Where is the part actually? What am I actually looking at? Because as you know in manufacturing, not very often does the part actually match the CAD model that was your idealized version. That data will be ingested by Obsidian to then go and make the plan of how I should go and weld this. Our sensors, our models can really be embodied in anything, but we're actually even looking at mobile platforms like our friend Rove here, where we take that same sensor stack, that same intelligence, but we put it on a mobile platform that can move around. This is really, really valuable for an application like shipbuilding, where you have something as large as a ship that's never going to go in a building into a welding cell. So you need a mobile platform that can move around the yard, can find the seam, scan it, and use that same intelligence to weld seam by seam in a mobile platform. You're bringing these onto the ship, in a bulkhead to work in a room day by day, things that would never be possible to automate with a traditional welding automation or traditional cell. So our friend Rove here can go in, can work in that environment and weld. So just a great example of that same sensor stack, the same intelligence, but on a mobile platform here instead of something more fixed like a welding cell. And we have customers that have and want both. The fixed cells work really well for a lot of our applications, but we quickly realized that a lot of stuff will never make sense in a fixed cell. So we spun up that intelligence on a more mobile platform. So really evenly split, honestly, in the demand there. That's something that we identified early on, is the need to de-risk automation. So many people have told us that they buy a robotic arm, it works great for a year or two, maybe the programmer leaves and all of a sudden it stops working, now it's just under a tarp in the corner of the site. We have a robots as a service model, no upfront capex. We are ensuring your uptime, we are ensuring the cell is running efficiently, we are on the line to make sure you're running well, and people are super open to this idea because so many people have been burned with traditional robots. It's really de-risking that for them, de-risking the upfront capex, allowing them to implement robots at a much lower risk than historically been possible. A lot of pole work, so these really, really large utility poles that have this heavy multi-pass welding on the base plate here. So we do a lot of these utility poles for the grid right now, and then we do a lot of that data center work, which I mentioned, and then heavy industry, tractor trailers, mining equipment, all of these really heavy welding applications. So the options were to try to hire more people, which they're all doing and have been doing and will continue to do, or it's how do I fix my fit up issues, how do I fix my part variation, and that leads to just insane amount of expenses. Why does traditional automation work so well in automotive? Because companies can afford to spend $100 million, $200, $300 million on a perfect assembly line where parts are a perfect inch every time, and they're in very expensive fixtures coming down the line. Really just not an option for most manufacturers. So now we give automation that adaptability to kind of work and be able to adapt in real time. We'd love to chat with you. Make sure you follow us at Path Robotics or path-robotics.com. We're having a great time here at Automate. Thank you.